Alright, Math 3. We're looking at some word problems. Today I don't have the word problems there for you. I'm not going to read them all out loud. But I do want to kind of run through so you can look at some work that we did today. I won't do a whole lot of talking with this. First thing, this problem number 2 talked about the length of a photograph. I'd remind you on all of these problems, if there's not a picture drawn, you should draw a picture. So you can see I've drawn a picture of a photograph. It's not beautiful. We know that to find the area of a rectangle, we're going to do length times width. So we had to read through the problem to figure out the length and the width. They told us on this problem that the length is, and they said it right there, the length is 3 less than twice the width. 3 less than twice the width. I write like this. And they never tell us the width. So I can come over here and label those, or I can just identify those and then plug them into my area formula. So we plug those into our area formula. Okay. From there, we're going to distribute. And once I distribute, I recognize that it's quadratic. Some people don't recognize this as being quadratic up here, but it is an area problem. Area is always in square units, and it should be quadratic. And sure enough, it is quadratic. Because it's quadratic, and we're going to use the quadratic formula, I subtract that out to make it in standard form. And from here, we are going to use the quadratic formula. And we've already got that practice from the last couple days of using the quadratic formula. So from here on out, I use my A, B, and C to the quadratic formula. Now, I'm going to be quiet here. I'm just going to let it run, and you guys can watch this. Take your time, hit pause as much as you need to. Make sure you understand the substitution on each of these, especially on this one. I tried to color coordinate it for you. Okay. Again, take your time running through that, but at this point I realize with the plus or the minus that I have two answers, as most quadratics do. Two answers. I've got a positive 6 and a negative 4.5. Well, I have to think about the context of this problem. X here was representing, let's see, yes, that represented my width. So I can have two possible widths. I can either have a width of a 6 or a width of a negative 4.5. Now, having a width of negative 4.5 doesn't make sense, does it? So having a width of a negative 4.5 doesn't make sense. So I'm just going to cross that out and throw that away now. Now, width must be a 6. If the width is a 6, I can use my original description to find 2 times the width minus 3 to find the length is 9. So my thing must be 6.9. Next problem was again had to do with rectangles and squares and stuff. A new window is being replaced. And at this point I wanted to stop. When I drew this, remember they said the original window was square, but I didn't know how big it was. But they did tell me that it increased by 3 and by 2. So by drawing this picture, I can see clearly that this side right here is x plus 2. And that this side here is x plus 3. And those are the lengths and widths that I need. If I FOIL those out and then put it in standard form, I recognize I've got a quadratic. So once you've got the quadratic, we're going to switch and use the quadratic formula. Again, what happens is I recognize that I have two possible answers, 3 and negative 8, but I can't have a negative square. So the width couldn't possibly be negative 8, so I just crossed that out, and the original width of the square must have been a 3. Now on this one, I'll slow it down a little bit. On this one, they gave me an original picture that was 5 by 12 of a garden, I think. And then they said it was increased by the same amount. So look, I increased both sides by the same amount. Now, of course, I don't know what that amount is, but it creates a new situation here. X is the amount that it was increased. So since the total length on one side is going to be 12 plus x, or x plus 12, and the total length on the other is x plus 5, I can FOIL that out. And then once I FOIL it out, I get it into standard form by subtracting 120. And now I'm ready to use the quadratic formula. As always, I end up with 2 answers, and because of this situation again, where I'm in a geometry situation, most of the time my negatives don't make sense. So one possible garden would be 8 by 15 by plugging in this 3, and the other garden would be, I started off and I found out it would be a negative, and that doesn't make sense, so I just threw it out. Guys, that's the idea. I want you to work on 1 through 5 tonight, and we'll look at those tomorrow.